All right, so thanks for coming to this session and welcome to Las Vegas. My name is Massimo Refere. I'm a principal technologist with AWS. I've been with AWS for about 4 years. Oops, you need to switch it. So I've been with AWS for about 4 years, 3 of which with the AWS containers team, where I've been focusing, thank you, where I've been focusing on obviously containers and everything that relates to the services that we have released to allow you to run a container image, which is the topic of the session, right? So basically what we're going to do in the next hour or so is to try to navigate the, someone says the complexity, we like to say the richness of the portfolio, to give you more insights about which container service to choose depending on your specific need and depending on the, on the context. I'm not going to bore you why containers are becoming the new normal, because if you are in this room, I am going to assume that you do have a container, you're trying to figure out how to run it on AWS, which is, as I said before, kind of the topic of this session. You can read here some of the obvious reasons why containers are getting attention in the industry, and they have been getting attention in the industry in the past few years, but this session is not going to be about why containers, right? So the assumption here is that you are already picking that form factor. The other thing that I would like to briefly cover is that AWS customers are broad and diverse, right? So they come from very different background. They come from very different industries. They come from very different experiences, and they have a different level of maturity when it comes to cloud and cloud deployments and even containers. Some of them try to over-index or try to optimize for different dimensions and for different vectors, right? So some customers, because of where they're coming from or where they want to go, they may want to optimize for flexibility, for example, because they think that they are unique, or maybe they are unique and they need all the flexibility that they can get to customize the deployment in their own way. Other customers may need more flexibility, more agility or simplicity, for example, right? Because maybe they do not have all the ops power that big customers have. So they're looking for something that is easy to use, easy to operate. So it's not easy to find a single product that can serve all of the vectors, right? So that is one of the reasons for which we have multiple technologies and multiple products that try to fit a given requirement or a given situation. So the challenge here, which I started to describe very briefly, and the goal that we're going to try to achieve, to try to find a way to say, you know, can we build a decision tree that can authoritatively point to a product that I would need to use to deploy the container image that I have, right? And this is a big challenge, right? I usually joke about the fact that asking this question, tell me which product I should use to run my containers, is akin to asking for a checklist to land a Boeing 747, right? It's very difficult to answer that question without having all the context and without having all the knowledge about, you know, what you need to do, where you're coming from, and all of the dimensions that we have alluded to at the very beginning. So one of the things that I would like to start with is that there are no 17 or 32 ways to run containers on AWS, and you may have heard this joke. By the way, we're being recorded here, so we need to be a little bit professional, because otherwise I would ask you to take a picture of this and tweet it, tagging Corey Quinn about what we're trying to do here. But seriously, what the way that I like you to think about the products that exist on AWS that can run containers is in these 4 buckets that we're going to discuss now. So the first bucket, which is, by the way, something that we're going to focus on the discussion, is that bucket that says there are services on AWS that allows you to bring your generic container image and run it on your behalf, right? So basically, these services are easy to depict, like, for example, Amazon ECS, Amazon EKS, Lambda, AppRunner, if you heard about those. So those are services whose only mean is to allow you to run container images in a more or less sophisticated manner, but that's their purpose. There is a second bucket of services that are similar in nature, meaning that they allow you to bring your container images, but their meaning in life is to provide added value, right? So their value that they provide is not just that they allow you to run containers on AWS, but they do something special for you. Think about, for example, AWS Amplify, IoT Greengrass, Elastic Beanstalk. All these products allows you to bring your own container image, but that is not usually why you pick those services. You pick those services because, for example, in the case of Amplify, you're building a mobile app or a front-end application, and the service also allows you to bring your own containers, I would say almost incidentally. There is a third bucket, which is similar to the second, but the big difference here is that it doesn't allow you to run generic container images, right? So think about, for example, SageMaker, EMR. All these products work with containers, but the fact that they can allow you to run containers, it doesn't mean that you can bring anything that you want. They either provide you with containers, so the service provides you containers that you can run inside the service, or they provide a very prescriptive way to build those containers to allow you to run those containers in the context of that product. There is the last bucket that is basically, you don't even see containers. So the service itself, the product itself uses containers, but you don't have to know about the fact that the service uses containers. More and more of our services are built on top of container technologies. You don't even see that. Examples of these are, again, AWS Amplify, AWS AppRunner, and many, many other services are built this way. Now, as you can see here, one of the complexity about picking one product is that they may fit into different domains, right, or into different buckets. Like AppRunner, for example, fits into bucket number 1 and bucket number 4, Amplify, bucket number 4, and bucket number 2. So this is part of the complexity about what does this product do actually when it comes to containers. So the long story short is that basically in the fullness of time, all AWS products may potentially fall in these buckets, 3 and 4. All of our products potentially may end up being built or leveraging containers. That doesn't mean that you can take an arbitrary container image, say Nginx, for example, and run it in those services. They just leverage and use the power of containers. What we're going to focus on in this session is the first two. So these services or products, they basically answer the question of how can I run my container image, my arbitrary piece of code that has been wrapped into a container image. So this is what we're going to cover in the rest of the presentation. So basically, the idea here is that maybe in 2 years, in 5 years, there is going to be 100 services that can run containers on AWS. But this doesn't mean that you have a portfolio of 100 services to pick if you have an image that you need to run. So what are the options to run containers on AWS in the context of those two buckets? So before we go and list all of these services, think about how you deploy containers on AWS. And I like to think about these as a 3 layers mechanism. So the 3 layers are the capacity layer. So basically, this is where CPU memory, the resources, the infrastructure resources are coming from, right? Because that container needs to run on something at the end of the day, and it needs to consume those resources. There is a second layer that is the orchestration layer. So imagine that you need to run 1,000 containers on 20 EC2 instances. Who is going to coordinate that deployment? That's the role of the orchestrator to deploy those. And then there is a third layer, which is what I refer to as the provisioning layer. So basically, this layer is what allows you to consume the orchestrator in a more simplified manner, right? Because getting access to the orchestrator may be too low level for what you need to do, and we provide technologies and products that allows you to abstract that complexity of an orchestrator. What does this mean from a product perspective? So if we go from the bottom up, capacity layer, think about Amazon EC2, AWS Fargate. With the enhancement that we have been doing and making with ECS Anywhere and EKS Anywhere, now also servers on-prem or edge devices are also considered capacity that you can use to deploy containers using AWS tools. So with ECS Anywhere or EKS Anywhere, for example, you can deploy your containers using AWS mechanism, using AWS APIs on capacity that is outside of the AWS region. From an orchestrator perspective, there are 3 orchestrators that we provide: Amazon ECS, Amazon EKS, and Red Hat OpenShift on AWS, which is a co-managed service between AWS and Red Hat that allows you to run OpenShift on AWS in a fully managed manner. The third layer is the provisioning layer, which is basically a set of products and tools that typically interface with those orchestrators that hide the complexity or the richness, depending on how you want to see it, of the orchestrator. There is an additional product, AWS Lambda, that allows you to run containers, but we will come back to this, that is a little bit out of context in the context of these 3 layers, right? So AWS Lambda, I joke about the fact that it's a little bit weird, but weird in a good way, in the sense that a single product embeds all of these 3 layers, right? Lambda capacity that you don't obviously see, the orchestration mechanism that allows you to run Lambda functions, and then obviously the interfaces are so easy to use that it's fair to consider that a provisioning layer as well. A different way to look at these chart is with another more architectural view of the same things, but with the added value of trying to think about how they coordinate and how they relate to each other. So in this slide, I'm going to make appear again all of those products that we have just discussed with some of the relationship that exists between them. I'm also going to call out what I refer to as ways to run containers in AWS, and we'll talk about these in a second. And those are marked with that red circle or orange circle. So at the bottom, there are those capacity products, right? EC2, Fargate, traditional servers, on-prem or edge devices. On top of it, there is ECS, EKS, and ROSA, Red Hat OpenShift on AWS. In addition to those, as we mentioned, there is Lambda. Lambda, as we said, it's weird in a good way that it stands, by itself, right? It doesn't use Fargate, it doesn't use EC2. Well, it does in the backend. Obviously, those containers need to run on something, but it doesn't use EC2 explicitly. It doesn't use Fargate explicitly. And then on top of that, there are all of those provisioning products, right? So what you see on this slide is these 3 layers with all the relationship between them. We will cover some of these throughout the presentation, but the first thing that I want to call out in this slide, which is going to be very important, is one of the dimensions that we called out at the very beginning was this simplicity or easy of use, easy of operate. If you notice, some of these lines are dotted and some of these are solid. So the dotted line represents you're not going to see what happened in the back end, right? So a provisioner, let's take AppRunner, for example. AppRunner allows you to run a container. We say that AppRunner leverages Fargate via ECS, but you're not going to see anything in your account. So the dotted line means everything happens in an AWS account. We take full management of that stack behind the scene. Solid line means that everything happens in your account. Copilot is a good example of this. Copilot is a CLI that allows you to deploy patterns of application, like a load balancer front-end application or a bad job running on ECS, but it's basically orchestrate a big CloudFormation template that you will see in your account. So this is very important to keep in mind when talking about the value that each of these provisioners provide. The second thing about this slide is that usually what we see with customers that are approaching these choices is that there are really two big families of discussions that happen. So the first one is, I want to call it more strategic. And that discussion usually is done with a team of people that are building a platform internally to the organization to allow their developers to deploy containers, for example, in a platform kind of mechanism, right? So the way that works is that that team is going to make choices between ECS, EKS, potentially Lambda, even if Lambda spans between these two big patterns, but potentially Lambda. They're going to make strategic decision for the company which orchestrator they want to pick based on their needs. The second big patterns of these discussions happen at the provisioning layer. I call out that these are more tactical, or I would say less strategic discussions. And usually the discussions here are from single teams, people that have a finite set of applications that they need to deploy, and they're just looking for the best tool at hand to deploy their application, their containerized application on AWS. So they basically go and scan through the provisioners and to figure out what is the best way to deploy their own set of applications on AWS. So those are two big, as I said, discussions that usually happens. So let's try to dive a little bit deeper. Obviously, we are time constrained here. We can stay here like 2 days to discuss all of these. But I want to call out a few things that are important to remember when people go through this richness of the portfolio to make decision. So the first thing that I want to call out is you notice that there are a bunch of these products that are ways to run containers on AWS with the red circle that I talked about. As you can see here, Fargate is not a way to run containers on AWS, or I did not consider Fargate a way to run containers on AWS in the context of this slide. And there are lots of people that say, well, I'm using Fargate. I'm using Fargate to run containers on AWS, so why are you saying that? So let's switch to the obligatory slide, what is Fargate? Because we know that Fargate is so interesting and new to the industry as a model that it has created some confusion. So in order to define Fargate, let's start from the orchestrator. Let's pick, for example, ECS or EKS in this case. What does an orchestrator do? It does two things, right? So the first thing it does is it allows you to model an application through pods, tasks, services, deployment, depending on what you use in this case. It allows you to say, my application needs to be deployed in this way, right? 2 pods, 4 services, whatever that is, northbound part of the orchestrator. Southbound part, it manages cluster of machines. Typically on AWS, those are EC2 instances. If you're using Kubernetes, those are worker nodes. If you're using ECS, those are EC2 container instances. They basically come with a container runtime, container D, Docker, whatever that is at that point in time. And basically, the orchestrator create this notion of a cluster of EC2 instances where you're deploying your containers. In the example before, 1,000 pods or tasks deployed to 20 machines. That's kind of the scenario that we have in mind there. So what is Fargate? Fargate is a way to get rid of that cluster underneath. So Fargate is a serverless compute capacity to run containers on AWS, both for ECS and EKS. What does that mean? Why do I say that Fargate is not a way to run containers on AWS? Because at the end of the day, you're always coming in through ECS or EKS. A lot of customers are confused by the fact that I want to run containers on Fargate. They go on the AWS console, and they don't find Fargate. And that's by design, right? Fargate is not a customer-facing service. Fargate is compute capacity that is available to ECS and EKS to run containers without having to manage clusters of EC2 instance in this case, right? So your entry point is going to be always the orchestrator, and then you can pick Fargate or EC2. Now let's go a level up, and let's actually talk about the orchestrator layer, or those strategic decisions. The other thing that we hear a lot is customers, particularly those teams that are making those strategic decisions that say, should I use ECS, should I use EKS, or should I use Lambda to run my containers? Now, before we get into this discussion, I think we need to make and take a step back and define what a container is and what we mean by container, especially in the context of Lambda announcing last year support for containers. So when we talk about containers, and maybe most of you in this audience, when we talk about containers, we have something like this in mind, right? So basically, something like a container image, which is basically the packaging mechanism that allows you to package your prerequisite, your code, and a long-running process that runs inside the instantiated container that is what I refer as a traditional application or a long-running application. Think Nginx, think Tomcat, think anything that can bind to a port and just listen for someone to call it. That is what we usually think about what a container is. It's not by chance that we also talk about, well, a container should have a single process in it, right? So best practice is that a container should only have a single process in it. So we tend to conflate what's running inside the container and the container image form factor. Lambda does support containers, but it does support containers in this way. So basically what Lambda does is Lambda supports the container image form factor, or OCI, to allow customers to wrap that image in a container image. I'm sorry, to wrap the code, the function, in a container image. The function itself doesn't behave like a long-running process. So long story short, what I want to make clear is that when you hear Lambda supports containers, it doesn't mean that Lambda can run Nginx, okay? Lambda supports containers in the context of I can use my CI/CD pipeline that I have been using for traditional containers to also wrap Lambda functions, for example, okay? This is very important that we keep this difference between the packaging mechanism and what's running inside. So a better or a different way to explain this is that imagine that you have a traditional application, long-running application, in this case running on top of ECS, right? So basically this has been binding on port 80, for example, or whatever, and it's waiting for connections to happen. So when an HTTP request comes in, that process responds to that HTTP request, right? When another one comes in, it responds to that one. A different application may be pulling an SQS queue. So that process continues to run. When I say that process continues to run, I mean you're paying for that, even if nothing is showing up in that SQS queue or nothing is touching that HTTP endpoint. When something shows up in SQS, it will take those messages and it will elaborate them, okay? The way you scale this is, oh God, I need more resources, right? I'm getting so many HTTP requests, or my SQS queue is growing so much that I need more capacity to run through that. So that is why you scale those pods or tasks, for example. And you're paying for that capacity, of course, for what you're actually running there. Lambda is very different in this context. Lambda, well, first of all, as you can see here, I like to say that a traditional application runs on ECS, on the AWS infrastructure. Lambda or a serverless application runs inside the AWS infrastructure. If you think about Lambda, or better, a serverless application is comprised of many different things. It could be Lambda functions, it could be step functions, it could be a configuration of the API gateway. So basically what you're building is you're building your application inside the AWS infrastructure. And the way it works is it's an event-driven model. So basically, if you're doing nothing, you're not paying for anything. When an HTTP request comes in against the API gateway, what happens is that will trigger an event that will run a Lambda. Okay? Another HTTP request comes in, another event triggers a Lambda function. And you're only paying for that Lambda function. Same thing for, let's say, SNS. A new thing comes in, it generates an event, and it will trigger a Lambda function. You're only paying for when that Lambda function is being triggered. Very, very different model, even application model, or development model, if you will. So how do we think, or how would you like you to think about ECS versus Lambda versus Kubernetes? So as you can see here is a bunch of AWS services driven by the AWS API, and among them there are ECS, EKS, and ROSA, and Lambda. So they all respond to AWS API, which means that if you're deploying to ECS or Lambda, as we discussed, you're using those APIs to deploy those workloads. With EKS and ROSA, it's a little bit different, right? So when you deploy an application, you're not talking AWS APIs. You're talking Kubernetes APIs. What does that mean? That means that EKS and ROSA are not control planes, right? You're not saying to EKS, deploy this Kubernetes application. You need to think about EKS, in that case, as a Kubernetes cluster vending machine. So you can tell through the AWS API to the EKS API, can you build a cluster for me? Once that cluster has been created, and as you know, Kubernetes is kind of infrastructure agnostic, so it needs to tie back to the infrastructure using typically, daemon sets, webhooks, operators, CNI driver, CSI drivers, whatever that is. So that is where the mapping exists, so that you can talk Kubernetes API and deploy stuff using the AWS capacity. So where do you use which? To make a very long story short, and this is where it gets complex, and this is where it gets akin to the give me a checklist to land this Boeing 747, is we can say that you can use ECS for traditional applications, so long-running application that we have seen before, optimized for low operations, right? So there isn't much that is going on. A lot of the things are managed by AWS, and ECS is a natively integrated service compared to all the other one. Lambda, similar in terms of operational efforts, probably lower than that, because there are even less moving parts that you need to manage, but it's typically oriented through new applications because of what we said, right? So the traditional long-running application cannot really run in Lambda, at least they cannot today. So this is usually, serverless applications are usually for new applications. And people that use either EKS or ROSA are usually for optimizing for flexibility, infrastructure independence, and extensibility, which is actually the power of Kubernetes. So this is how we tend to kind of in that context of give me a checklist to land a Boeing 747, we try to summarize when to use which is not very easy to do for the reason that I just mentioned. There are a couple of things that are at play in this slide. I want to spend a couple of minutes on this slide because I think it's important that we call them out. There are usually two vectors that drive customers throughout picking solutions here. This applies also to the provisioners, but I think that it applies even more to the orchestrator and to these three services specifically. So the first one is mobility, right? Flexibility. Can I take my application and move it somewhere else? So the idea on this slide is that the higher the application is positioned on this slide, the higher flexibility you have to move it. Think about this. If you have code that you wrote specifically for Lambda and for a serverless application, that code is basically bound to the AWS infrastructure. If you're using ECS, the code is not bound to AWS, right? Because you can take that container that is running on ECS and running it on your laptop or run it in your data center. The choreography around that container, the YAML that's deployed on ECS, it's bound to the AWS infrastructure. So kind of, portable, but to an extent. Kubernetes, absolutely. Because basically you're talking Kubernetes API, the choreography is portable as well. Not just the container, not just the application. You can take the same YAML that you deployed on AWS and deploy it on-prem on a Kubernetes cluster on-prem or on a Minikube cluster on your laptop. So this is one of the vector the customer pick. The other vector, and they usually go the other way around, right? You cannot have both. The other one is what I call the mean time between update. Basically, how long can you run an application without ever touching your infrastructure? And this goes back to, is it heavy to operate or is it easy to operate? I do have a Lambda function that I forgot actually that has been running for like 4 years when I joined AWS. That application still runs basically supported with no security issues whatsoever, because that application runs inside the AWS infrastructure, and we take the majority of the burden of managing that application, right? As you move up the stack, the burden of operation, the higher the application is positioned on this slide, the harder it is to manage that application. Or the mean time between updates becomes shorter. Think about Kubernetes, the fact that you need to keep up with the new releases, right, just to be supported, right? Obviously, we help with that, but at the end, it's a lot of, customer responsibility to make sure that you're running the right drivers, the right things to run your application in a supported, secure way on top of Kubernetes. So these are these two sliding things that customers need to decide on in terms of, do I need more of these or do I need more of that? So let's switch to the provisioning products very quickly. So we cover like the capacity. We talk a little bit about the orchestrator and those strategic choices that we see customers making. Let's talk a little bit about these provisioning products. How are customers adopting those provisioners? And we see two different type of discussions here. So the first one is similar to what I was alluding to at the very beginning, like people with a limited set of application, I just need to, deploy these 3 applications, and I just need to do that in, the simplest way possible or the flexible way possible. I don't really care about, what's running underneath, right? So, so as I said in this slide, some will start with a provisioner and won't care about what's running underneath, which orchestrator or whatever. A good example of this is AppRunner, right? So people that pick AppRunner, a fully managed service to run web application in a request response mode. They don't care about what's running underneath App Runner. Actually, they don't want to know. There is a second pattern that we have seen, and it's the other way around. So there are lots of discussions about, which orchestrator should I use, and maybe platform teams land on a specific orchestrator. Let's say that they land on ECS, but they want to give something to the end users that is easy to use, right, to deploy to ECS, because deploying directly to an orchestrator, whether it's ECS or EKS, is not easy for a developer. So maybe these customers are going to pick something like a Copilot, which is that CLI that I was alluding to before, which hides a lot of that complexity. So instead of writing 500 lines of YAML that says deploy this web application on Lambda using the ALB, whatever, on top of ECS, I can use Copilot to say deploy a load balancer off of this container image, and it will go and create those 500 lines of YAML. So remember that there are these two kind of ways to come in from a provisioner perspective. So let's go very quickly through all of those I have discussed before. So App Runner, we have already talked about this. I wouldn't say extensively because we have just mentioned it, but basically App Runner is we like to say that it's the easiest way to run this request response web service pattern on AWS. If you have an application, let's say Nginx, for example, again, or anything that implements that request response type of patterns, App Runner is probably the easiest way to run these on AWS. As you can see, all dotted lines, which means that everything happens in AWS accounts. You don't see anything. When you deploy an application on App Runner and you go and check, ECS or anything, it's not using ECS in your account. It's using anything or everything that is in AWS managed accounts. Docker Compose is another one that is very interesting to customers that are all into the Docker ecosystem and the Docker Compose particularly tool set. So there are lots of customers that has invested a lot of time and resources in building deployment mechanism using Docker Compose. And we have been working with Docker to introduce inside Docker. So this is not an AWS technology. This is support that exists inside the Docker technology. So basically, you can do Docker Compose up of your Docker Compose and deploy to AWS. The way that it works is that Docker has introduced context in the Docker CLI that allows you to say, by default, deploy to my local machine, but you can create another context pointing AWS with your account and credentials, and by switching to that account and doing Docker Compose up, it will deploy to that endpoint. As you can see here, it's all solid lines, which means that what Docker does is just creating a bunch of CloudFormation templates that it will deploy through CloudFormation. So if you go into CloudFormation, you will see that stack being deployed. If you go into ECS, you will see all of those resources being deployed. But this is often the entry point for customers that don't care about what's running underneath. I just have 3 Docker Compose files. I just want to deploy on AWS. That's kind of a good choice. Copilot. I have discussed about Copilot already. It's basically a CLI, easy-to-use CLI, that allows you to deploy to ECS using those patterns, right? This is where it gets confusing, right? Because Copilot, in addition to be able to just deploy those baked-in patterns to ECS directly, Copilot can also deploy through App Runner. So a provisioner that leverages another provisioner to deploy. So you can think about Copilot more like, I don't want to say like the container CLI going forward, but you could expect Copilot to introduce even more support for other provisioners. So Copilot could become potentially the entry point for deploying either directly to ECS or App Runner or other services potentially. Lightsail is another interesting one. So for those of you that do not know, Lightsail is kind of a parallel universe to AWS, which we have built for traditional VM hosting for people that do not need the richness of AWS. So it's as I said in the slide, it's a very intuitive way to run containers and more, because this was born as a VM hosting service that also added database support. But the characteristic of this is it's very easy to use, very UI-driven workflow for people that are not very familiar with the technology. And it also comes with an interesting packaging mechanism for pricing, right? So instead of being like a pay for what you use, it just bundles everything, including traffic, network traffic, which is included in those packages. So very easy to use for those that are not very much into AWS. Batch is another interesting one. AWS Batch, you can think about AWS Batch as a vertical solution that we built on top of ECS to allow customers to deploy batch type of workloads on AWS, leveraging ECS, but providing those enhanced mechanism for scheduling, priorities, all those things that people with large and complex and sophisticated batch jobs are looking for. The alternative in this case would be, well, I can use ECS, but I need to reinvent all those added value from scratch, right? Whether AWS Batch provides that those mechanisms out of the box, basically. Amplify is another interesting one. If you remember, Amplify is usually, it falls into bucket number 2 in that original slide. And it's something that you would use to deploy containers on AWS if you're in that mindset or workflow of deploying front-end application. We rarely see Amplify being used if you have a container image and you turn to AWS and you try to figure out how to run that container. But if you are already in the context of Amplify, because you're doing stuff with Amplify where it shines in terms of developing new front-end type of application, that it also provides a mechanism to deploy your own containers outside of those workflows for building front-end applications. Amplify can also deploy to Lambda. So it's a provisioner that, similar to Copilot, provision to both ECS as well as another provisioner, depending on the workflow that you pick. But as I said, you probably are going to use Amplify if you are already doing some of those things. Elastic Beanstalk is also interesting, and it falls pretty much in the same bucket as Amplify for the value that it provides. And the value that it provides is typically, I don't have a very ops strong team. I want AWS to do the magic. I just want to bring code, and I want AWS to deploy that code for me. That is the magic that Beanstalk provide. But Beanstalk also provide mechanism, I would say rudimental mechanism, to deploy your container image. So if you have a container image and you have never used Beanstalk, it's very rare that you would pick Beanstalk to deploy that container image. But if you know Beanstalk, if you know, if you already use Beanstalk, that becomes natural to say, well, I want to also leverage Beanstalk to deploy these 3 applications, these 3 containerized applications. The thing to notice about Beanstalk is that it doesn't even go through an orchestrator. So it's so rudimental that it doesn't even talk to ECS or EKS or any other orchestrator. It just deploys, which I call like an outlier in the context of what we're discussing. Greengrass, similar in concept to the other 2. You wouldn't probably say, well, I need to deploy a container on AWS. I'm going to pick Greengrass. You're probably going to pick Greengrass if you have an IoT project. As a matter of fact, Greengrass only makes sense to deploy containers on edge devices because Greengrass supports containers, but only makes sense to deploy them on edge devices for obvious reasons. The reason for which I wanted to include Greengrass in the scope of this presentation is because we are already seeing some small overlap and discussions with customers that say, if I need to deploy a containerized application on some edge device, should I use ECS Anywhere, which does support deploying on Raspberry Pis, for example, or should I use IoT Greengrass? Now, that depends on the context and the scenarios. Obviously, Greengrass may make more sense if you have a very solid IoT project that allows you to also benefit from the portfolio of the other IoT clouds. And ECS Anywhere may be a good fit for maybe a smaller deployment or a deployment that doesn't have all the traditional requisites of an IoT deployment. One thing that you may have noticed is that a lot of the provisioners that we have been discussing are all going through ECS typically, right? This is because the way that you need to think about our portfolio is that EKS and ROSA to that extent are, but specifically EKS, I would say, they are a very, solid, easy to run, Kubernetes barebone infrastructure on top of which you can pick and choose the Kubernetes ecosystem, typically the CNCF ecosystem, to pick the provisioner, so to speak, that you want, right? So far, we don't have a very opinionated set of provisioners that we built on top of EKS. This is not an option that we're ruling out, but it's the way that the portfolio is structured at the moment. So EKS, it allows you to provide that capability of taking anything that is Kubernetes compatible or requires Kubernetes compatibility and use it on top of ECS. And as I said, ROSA to a certain extent, because ROSA already includes a lot of these tooling and higher level services. Now, before we end the session, I wanted to give you a little bit of more hints about how we're thinking about how to explode this. So basically what we have seen is this is how you need to think about, containers and on AWS and the portfolio that we have. One of the things that we have been thinking about is how do we create something that is easier to consume for customers, other than standing in an hour presentation that probably answer, I would say, maybe if I'm lucky, 20% of the questions that you have. Because as I said, this is like providing a checklist to Boeing 747. So how can we provide an easier to consume way for you to say, I need to run this is my context, what should I use? So the first thing that we have been trying to experiment with is this product scorecard kind of concept, right? So basically the idea is, if we call out a number of dimensions, and we have already mentioned some of them at the very beginning, but think about, workload types. What type of workload types can I run on a given service? What type of capacity my service or my product is able to deploy to? Is it limited to EC2? Is it limited to Fargate? Or can it deploy to edge devices, for example? Easy of consumption. Is it easy to consume or is it difficult? Is it overwhelming to consume? Same thing for operations, because there are two different things, right? You may have a product that is super awesome in terms of the interfaces that it provides, so it's easy for a dev to consume, but to manage it and to manage the day-to-day operations, it may be a big mess, maybe. So maybe it's good for the first, but bad for the second, maybe. extensibility, hybrid support, which ecosystem does it have, scalability. Is it scalable, or is it just good to deploy 20 containers? Because actually, I have like 1,000 containers that I need to deploy. So what if we can come up with something like this? Like for each of the products that I want to hide for this version, because I didn't want you to focus on, oh, EKS is good here, is bad here, ECS is good here, is bad here, right? I just want you to focus on the concept here, because this is not baked into stone, and we're still working on some of these things. But basically, if we can create these scorecards where you say, well, as a customer, I would like to go here. I'm coming from here, and I would like to go here. To me, simplicity is absolutely important, right? And there is someone else that says, well, I have 20 engineers, and I do have very peculiar needs. So I need all the flexibility that you can give me. So basically, you could go on a scorecard like this and say, which are the products that allows me to actually pick what I actually need. The last slide that I wanted to show you before we close down is, can we actually build a checklist to Boeing 747 with all the risks that are associated to this, right? If you give me a checklist to Boeing 747, you don't want to be on that flight, probably. But in the context of, can we make someone more informed in terms of which products they should be picking based on who they are and where they're coming from? So this is another thing that we're experimenting with. This doesn't exist, of course, and it's a prototype. It's just something that we have been playing with. But imagine if there was a tool that allows you to say, I am an individual developer, or I am a startup. I want to deploy a web service, and I want to use the AWS API, and the programming model that I'm using is the traditional programming model, and I want a super easy way to deploy things. Then we may suggest, well, you may be looking at AppRunner, for example. Or maybe you come back and say, well, actually, I want to embrace the model, serverless. I'm not sure if you see this, but basically, it picks serverless, and it shows, well, maybe Lambda is what you need in this case. So again, this is kind of the least to land the Boeing 747. So there are lots of risks associated to this, but it's better than nothing, we think. So if you have any comment about where we should go with these, or if you have any particular ideas that you want to share in terms of what you would like to see when you're confused about what you should be using, please reach out, because we're looking for feedback in terms of how we're thinking about these sort of things. So with this being said, this is all I had. We have 6 minutes left. If there is any question from the audience, we don't have a mic. So if there are any questions you can ask, I'll try to repeat them. These are my contact information. If you're shy, you don't want to ask a question during the session, feel free to reach out. Twitter, email is the best way to reach out. If you have any particular feedback about presentation or actually the journey that we're on, we would like to hear that. So thank you very much.